Hi, welcome back to my YouTube channel. I am Likita from CSE branch. I am pursuing my education in Sri Venkateshwara College of Engineering, and my today's topic is Introduction to CAD, explanation about lines and points. Content, design process, points, projection of points, orthographic projections, lines, projection of lines. Design process goes on like this: visualize, problem identification and exploration of ideas, sketch, draw, design and record initial ideas, geometric models created from sketch, used or analyzed, detailed drawings and 3D model, refine, optimize and record the precise data for production process or implementation. Here visualization is the ability to mentally picture things that do not exist. Communication refers to the design solution should be communicated to others without ambiguity. Then it comes to documentation. Permanent recording is called as documentation. Okay, here in the first picture, a point A in first quadrant, the points are situated above HP in front of VP, so it refers to the first quadrant. When we observe from the top view lies on HP and the front view lies on VP. The horizontal plane is rotated in 90-degree in clockwise direction. So in the orthographic projections, we can see the front view above XY line and the top view below XY line. In second picture, you can see a point A in second quadrant, that is above HP, behind VP, where the point is situated. Then when we consider the top view, where the top view lies on HP and the front view lies on VP, so HP is rotated 90-degree in clockwise direction. So both front view and top view lie above the XY line. And in the third diagram, third point A in third quadrant, that is below HP and behind VP. So the point is lying in the third quadrant. The top view lies on HP and the front view lies on VP. HP is rotated 90-degree in clockwise direction. So the top view lies above XY line and the front view lies below XY line. In the fourth quadrant, a point A in fourth quadrant means below HP and in front of VP. So the top view lies on HP and the front view lies on VP. So the HP is rotated 90-degree in clockwise direction. So both top view and front view lie below XY line. So this is the common positions you get in the quadrants. That is, in first quadrant, front view lies above XY line and top view lies below XY line. In the second quadrant, both front view and top view lies above the XY line. In third quadrant, top view lies above XY line and front view lies below XY line. Then in the fourth quadrant, both top view and front view lies below XY line. And you can see the projection of point in the first quadrant. There are three possibilities: point A above HP and in front of VP, and point A above HP and in VP, located in VP, a point A in HP and in front of VP. These are the projections which we can do. Orthographic projections. It is technical drawing in which different views of an object are projected on different reference planes, observing perpendicular to the respective reference planes. The reference planes are horizontal plane, vertical plane, and side or profile plane. There are two types: right profile plane and left profile plane. And different views are top view, front view and side view. Top view is projected on VP and front view is projected on HP. Side view is projected on profile plane. Depends on right profile plane or left profile plane. Important terms of orthographic projections: planes, pattern of planes and pattern of views, methods of drawing orthographic projections. And you can see an orthographic diagram seen here. So these are the two examples of points. Point B is 40 mm above HP and 25 mm behind VP. Draw projections. So 40 mm above HP and 25 mm behind VP means it's in second quadrant. So first you take line and move the cursor on XY line. Give the length as 25 mm and angle as 90 degree. Press enter. then you get a 25 mm line, and then from that 25 mm line you can give 15 mm and again 90° and press enter. You could see 25 mm and 40 mm lines. For visibility of dimension, you can use smart dimension. Then second example, point C is 40 mm below HP and 25 mm behind VP. Draw projections. 40 mm below HP and 25 mm behind VP means third quadrant. So in third quadrant, top view lies above XY line and front view lies below XY line. So you can select the line and then move the cursor on XY line. From there you can give 25 mm length and a 90° angle, press enter. You can see a 25 mm line there, and in the next projection you can move the cursor to the point where the first starting line was, and then you can give the length as 40 mm and angle as minus 90° and press enter. You could see a 40 mm line there. Use smart dimension and draw the points top view and front view. So notations used for top view, A small a, and for front view A dash, and side view A double dash. In lines we use AB, A dash, B dash, and A double dash, B double dash respectively. Okay. In lines, basic you have to know about continuous line, and one is thick line, one is thin line, and dash line, and centered line used for locus. So projection of lines. In that, notations used for straight line are true length of the line, front view length, top view length, and in projector's distance. And angles are mentioned above. Inclination of true length of line with HP, inclination of true length of line with VP, which is represented by phi, inclination of front view length with XY line represented by alpha, inclination of top view line with XY line represented as beta. Lines in different position with respect to HP and VP and profile plane. Lines perpendicular to profile plane and parallel to both HP and VP. Line perpendicular to VP and parallel to both HP and profile plane. Line perpendicular to HP and parallel to both VP and profile plane. So now let's see the example of point. Draw all three views of point P lying 60 mm below HP and 70 mm in front of VP. This means the point is in fourth quadrant, and 40 mm from right profile plane. Also state the quadrant in which it lies. So it's fourth quadrant. So both top view and front view lies below XY line. You can click line here. See whether it is 0.35 because XY line is 0.35 thickness, and see whether it is continuous line. Draw the XY line here. This minus symbol indicates a straight line. Then use this text option to name it as X and Y line. Reset. Then again take line. So P lying 60 mm below HP. So it's front view. Place the cursor on line. Drag the line downwards. So give the length as 60. Enter. Angle minus 90. Enter. Then you can point a point here. Drag the cursor towards the end of the line. You can see a arrow here. Then you can give this as front view. So always top view and front view is mentioned in lowercase. So give P dash. Front view is represented by P dash. Within the bracket you can give front view. Then reset. You can measure the dimension by using this option, smart dimension. Click on the line and drag. Then reset. Then again take a line. 70 in front of VP. This is the top view. So click on the cursor, click the cursor here where you can see the arrow and drag the line downwards. Give the length as 70, enter. Then angle minus 90, enter. So we can change the thickness of the line by just clicking it and changing it to 0.13 mm. Then use point option, move the cursor on the line, give it as 2.0 mm. Where you can see the arrow, place the point there, reset. You can use smart dimension to measure the dimension, which is 70. It's correct. So next you can see here 40 mm from right profile plane means draw the x dash y dash line, that is 40 mm from this reference lines. So move the cursor here, then you can give the length as 40, then angle as 0. 40 mm line is placed there. Drag the line upward 90 degree, then downwards 90 degree. You can give this line as x1 dash y dash or x1 y1 line. Dash. And this as y dash. Okay, so the top view is lying, so we have to name it as top view. Top view is represented by small p. Then within the bracket you can mention it as top view. So now you can see top view is lying below xy line, so you can construct a line of 0.13 mm which is 45 degree below xy line. Give the angle as minus 45 because it's below xy line. Then you can measure the angle here by using this option. You can see angle between. You can press the xy line and the 45 degree line. You can see 45 degree here. Reset. Then again you can draw the line here. Extend the top view to the 45 degree line. If you cross the line, it shows 90 degree or straight line, but when you move to 45 degree line, you can see that 45 degree line turns red, so that is the correct position. Click here, then extend the line 90 degree above. Then again you can take line and extend the front viewpoint to that 90 degree line. So this point you can erase the unwanted line by using trim option. Now you can take point here, move the cursor on the line where you can see the arrow, place the point there. So first you should select 2 mm width, then you can give this as side view, that is represented by p double dash. Within the bracket you can name it as side view. Then you can use the leader option here to project the arrows. First click on the line and drag towards the point, and again click on the line, drag to the left side, then click on the line, drag towards down, and then front view is also extended like this, so click on the line, drag towards left, then again click on the line, drag towards left. So now we have constructed a problem here. All the three views are shown here. So they have asked the quadrant. You can, using the text option, you can mention the quadrant here. You can mention it as fourth quadrant. This is how you solve a point problem. So now let's see the example of line here. Line AB 80 mm long, true length is given here. Has its end A 20 mm above HP and 30 mm in front of VP. These are two reference lines and it is inclined 30 degree to HP and 45 degree to VP. Draw the projection of line and find the apparent length and apparent inclinations. So first we have to construct XY line. Take 0.35 mm. Then using text option you can name it as X and Y line. Above XY line it's VP, name it as VP, and below XY line it's HP. Then two reference lines are given here, 20 mm above HP, that is above XY line. Use offset option here, click on the XY line, then give the length as 20 and press enter. You can see two lines here, one above XY line and below XY line. Choose the line which is above XY line, press enter. Then to measure the distance between the line you can use distance between option, click XY line and the reference line. You can measure it's 20 mm. Then again you can use offset option, that is 30 in front of VP. So use offset, click on the XY line, and 30 mm in front of VP refers to the line below XY line. So choose the line which is below XY line. Then use distance between to measure distance between the lines. So it's 30. Now we can draw a reference line here. Then they have given 80 mm long, that is true length, and they have given inclinations 30 degree to HP. We have to construct in VP. So take a line here, move the cursor to the end of the reference line, click here, and you can give the length as 80, enter, then angle as 30, enter. So now using angle between option you can measure the angle, and using smart dimension we can measure the length of the line. Then again you can click on line option, move the cursor on the line towards the end. You can see arrow, click there, and you can give 45 degree. So length is 80 mm and angle is minus 45 because it's below XY line. Okay, now using angle between you can measure it's 45. Then using smart dimension you can measure the line, so it's 80. Then using the line which is centered line, you can draw a centered line here. This is the locus line, extend 0 degree line. Then again you can extend the backwards. Then you can do the same thing here also, extend the line here and then towards the back. Then you can extend this end of the line 90 degree towards the last reference line. So you can change this to continuous line by clicking on it. Then you can use arc by center point to draw arc and construct the front view. First you should click on the reference line and then you can click on the second reference line or 90 degree line. Then you can So it's not showing me correctly. So let me construct this first. Use arc by center first on the reference line, then on 90-degree line. So you can draw like this only. Afterwards you can trim using trim option. So let me make it as continuous circle. Then you can draw a small line here using trim option. You can now trim unwanted lines. So use trim option here, trim, then trim this, then this one, then you can trim this also, and this one. So then now you can use line which is 0.5 mm to draw the front view. You can move the line on the locus line. You can see an intersection point here. Click there. Then it's front view. You can give it as A dash and B dash. And this you can give it as B1 dash. Then you can do the same thing here also. First you should extend this line minus 90 degree towards the last reference line. So you can change it to 0.13 mm because it's reference line. Then by using arc by center you can draw arc here. First select the reference line, then the 90-degree line. Cut the arc here. Then using line which is 0.5 mm, draw top view here. Move the line on the cursor. You can see an intersection point here. Click there. Okay. Now we can measure the angle between, that is apparent inclinations, using angle between options. So it's 45, and angle between this, so it's 55. And you can measure the dimensions of top views and front views. For first let me name it as top view here, so it should be in the small letter, and this is B1. Now let's measure the dimension of top views and front views, that is apparent lens, 69.28, and this is 56.57. So let me use the leader to indicate the arrows here. So first I extended this line upwards, click on the line, down, then I extended this downwards, so let me mention the length, inclinations and apparent inclinations and apparent lengths here. E dash, B dash length is 556.57. Then EB length is 69.28. Then alpha is 45 and beta is 55. That's all about the line.